TTL or time to live. So in networking, what is this time to live? How it is related to the network, packet, etc. Now you see, here we have two kids. This is a piece of cloth and they don't want to keep it. So they are just passing it around. So what will happen to this piece of cloth in the end? In networking, the same concept comes here. We have a router, another router, another router. There can be many of routers. So a packet is coming to one of the router. It is sent to another router. That router sends it again to another router, again back to the previous router, and the destination of this packet is not any one of it. So what will happen to that packet? I'm talking about one packet. There can be millions of packets like this. So what will happen to a big network or in internet? Can we allow a packet to be there? Because it will create congestion. Because it is not reaching the destination, it is still there. So we cannot allow a packet to be roaming around for indefinite amount of time. Okay? There comes the time to live. That is why time to live is there. So the lifespan or the lifetime of the packet or the data that is being sent from the source to the destination is called or is determined by the TTL. That is from where it has started and at what time it has to be discarded. So time to live or TTL, it refers to the amount of times or hops. Hops means a packet exchanged between different routers. That is the amount of time or hops that a packet is said to exist inside a network, to remain inside the network before it is discarded or thrown out by a router. So we can also refer to this time as hops, which is the number of times it bounces between different routers. So the time and lifespan is decided by the TTL. Okay. So hops is just this R1 to R2 it goes, it is one hop. R2 to R3 it's a second hop. R3 to R1 again the third hop. R1 to R2 again 4 hop, like that, passing from one router to another, it is one hop. So the sole purpose of TTL or time to live, this field is to avoid a situation in which an undeliverable datagram or a packet keeps circulating in the network. Okay. So this is a proper value. If you see in this IP, we have IPv4 and IPv6. In IPv4 header, this field is time to live. In IPv6, the same thing is now called as hop limit. So they both are same. So it is a value in the internet protocol, 8-bit field in the internet protocol that tells a network router whether or not the packet has been in the network for too long and should be discarded. So because it is 8-bit, 0 to 255, maximum value is 255. So the maximum value can only be 255. So any value can be given by the operating system or the network. So in IPv6, this TTL is now changed to hop limit. So when this value, what is the significance of that value? When it goes from one router to another, the router will decrement 1 from that number which is assigned initially. Okay. And this has to become 0. When it becomes 0, that packet is discarded. If it is not 0, it is accepted. So TTL is also used in other contexts, including the CDN and the DNS, that is the CDN caching and DNS caching, content data network and this DNS, domain naming system. So it is all about a number. When a packet starts from the source, whenever it reaches a router, the number is decremented. Okay, for example, it goes to say 6 hop. So it will go to 6 hop. If the number is reduced by 1 and 1 and if it is not 0, then the packet will be delivered, otherwise it will be discarded. Okay. So it's all about the life of a packet.